قاعد اسوي
راح اقدمه انا حطيت المرتبط. لا هنا بقي احسن.
لا في نصيحة نعرفها انه نحكي واضح كيفك بعد.
هناك احسن.
هيك احسن شيء بالصوت بس شوف صوت.
I want to check the wide. Because I want to focus myself here.
هيك احسن.
Okay. Are you ready? Yes? Can we start? Yes. So, another topic I'm going to talk about is the inhibition of enzyme. طلاب اسمعوني. Am I right? Okay. In this slide, as you can see here, we have a classification of molecules that can control the activity of enzyme. They known as an enzyme inhibitor. They consider as a non-specific and specific. Today I'm going to talk about a specific. When your inhibitor bind to the enzyme, sometimes the binding of inhibitor to the enzyme sometimes is irreversible and sometimes is reversible. About reversible inhibition, we have a competitive and non-competitive. So maybe I ask you about competitive and non-competitive. They are considered as irreversible? No. They consider as a reversible inhibition. This is the first simplest question from the enzyme inhibition. What about we have two types of inhibition. I mean that reversible inhibition. As you can see here, when we say competitive, what does it mean? Yani there is a competition. Okay. For example, this chair is enzyme. Okay. And here you have an active site. Okay. Sometimes you can occupy, yani you can sit instead of substrate on an active site. Okay. Sometimes your inhibitor sits exactly at the site your substrate will sit. Do you understand? Yani the binding site of substrate and inhibitor is similar. Okay? So this type of competition known as a competitive inhibitor, actually this is type of inhibition. So what happens whenever your inhibitor bind to your enzyme? And how we can show in a Michaelis-Menten curve. As you can see here, if you have an inhibitor that occupies your binding site, you have to add it, as I mentioned, this is a reversible, okay? For example, this is a free enzyme, and I'm a drug as a competitive inhibitor, okay? When you take one drug, for example, a statin, for controlling, have you ever heard this name of drug, a statin? For controlling of cholesterol, okay? Statin, okay? Atorvastatin, darvastatin, we have a different commercial name actually. When you take inhibitor, your drug can sit on a substrate binding site, okay? But if you add in more substrate, you can take the drug, okay, from the active site. Yani, This binding is reversible. Do you understand? So, what does it mean? You require more substrate to take out your inhibitor. What does it mean about the Km? Aha! Km actually increase. Do you understand? So, what is important in the inhibitors? At first, you should, to be honest, this box is very important. From this slide. You should know that maybe I ask you, in the presence of competitive inhibitor, for example, Km constant, Vmax decrease. Km decrease, Vmax increase, okay? So you should know that in the presence of the competitive inhibitors, your Km increase, as you can see here, but finally, because you reach to the Vmax, we say that Vmax is constant, okay? And another point, competitive inhibitor can actually bind to the only free enzyme. Can I bind the inhibitor here? No. Because, for example, I'm a substrate, okay? I occupy the binding site. At first, inhibitor should remove me and sit itself, okay? Is it clear? So, this is the important point about competitive. But what are the examples? What are the examples? You know, as I mentioned, you have some allosterate enzyme. Allosterate means regulatory enzyme. You know, as a physician, you should ask some normal routine checkup. What is the routine checkup, for example? Fasting blood sugar, I don't know, triglyceride, cholesterol, HDL, LDL, okay? Urea for the kidney, for example. For example, after reading the lab results, you see that cholesterol is very high. But you should know that we have, are you familiar with the triglyceride and cholesterol? Two types of lipids. HDL and LDL are lipoproteins. They're full of triglycerides and cholesterol. Okay? I'm talking about simple lipids. Triglycerides yani three of what? Fatty acids. Do you have it in your high school?
No,
Triglycerides yani 3 fatty acid. They bind to the glycerol. Glycerol is alcohol. All yani alcohol. Glycerol, ethanol. All yani alcohol. What is all? Retinol. Aldehyde. Excellent. For example, vitamin A has a aldehyde form. The name of the aldehyde form is retinol. The alcoholic form is retinol. The acidic form is retinoic acid. Okay, in this semester you had actually this form. Okay, so for cholesterol, for example, if you should know that we have two important lipids, triglyceride and cholesterol. For example, kalle pache in Farsi, head and bache of the sheep. Bache, it's very delicious, okay, but it's full of cholesterol, okay. Yes, it's very common, especially as a breakfast in Iran. I actually really love all of these things. So, it's full of cholesterol. But if you have a patient who has a very high triglyceride and cholesterol, what is the difference? If your cholesterol is high, you are not a lucky person. But if your triglyceride is high, actually you should control your diet. What does it mean? You should know that 70% of the cholesterol, when you measure from the blood, you take at first, you take blood and measure the concentration of triglyceride and cholesterol in the blood. When the cholesterol is high, yani you are actually you are not a lucky person. Why? Because you should know that 70% of cholesterol synthesized in your body. It's not very related to eating kalle pache or kebab or other things. Only 30%. Okay? Only 30%. So you have to prescribe a drug for cholesterol. Okay? You have to prescribe for what? To control this 70%. For example, a statin. But if the triglyceride is high, okay, you can punish your patient. Have a regular exercise. Please do not fast food. I don't know, any kind of fats actually. Okay. So, as I mentioned, for controlling cholesterol, it's none of my business. My body synthesizes cholesterol. So, how can I control this one? By prescribing some anti-hyperlipidemic agents. Anti-hyperlipidemic agent means that some drugs that control the high lipid concentration in the blood. In the body, okay, for example, you have a several reaction and you start from this one to finally reach to the cholesterol. Cholesterol is the end product. Okay. In the body, the first reaction catalyzed by one enzyme, this is the full name is not important because in metabolism you will be familiar. HMG-CoA reductase. This is very, very important. The name of the enzyme is very, very important. HMG-CoA reductase is an allosterate enzyme. Is the name of the enzyme catalyzes the first reaction for production of cholesterol. Please tell me, if you block me, inhibit me, what happened? You stop biosynthesis of cholesterol. Do you understand? So, you as a physician, you prescribe some drugs and the name is a statin. Okay? So a statin blocks the first reaction. Okay? So, so do you understand? At first, the name of the drug is important. What is important here? Atorvastatin, pravastatin. These are the name of the drug for control high cholesterol. Which enzyme inhibited HMG-CoA reductase? And what is important? Maybe I ask you some, most of the time I ask pravastatin. Maybe I ask you, inhibition of HMG-CoA reductase by a statin belong to which class of inhibition? Competitive inhibition. And why? Because, for example, this is a form of the substrate, and this part of drug is very similar. When you have a competitive inhibitor, the structure of inhibitor should be similar to your substrate because they want to sit at the same site. They should be similar. Do you understand? So, another example. Methotrexate, inshallah, in a vitamin, the other professor will describe the mechanism. Just know that we have one drug known as a methotrexate, inhibits the enzyme di. This is not tri, okay? Di, especially dihydrofolate reductase, and this considered as a competitive. About the detail is not important. Inshallah, in vitamin session you will be familiar. Just know that inhibition of dihydrofolate reductase by methotrexate for the treatment of cancer and some autoimmune disorders belong to the competitive inhibition. As I mentioned, in vitamin session, you will be familiar with it. And another example of the competitive inhibition is that inhibition of the succinate dehydrogenase by the malonate. Malonate is inhibitor. I yani inhibitor. This is an enzyme, and this is the type of inhibition. So, this is the enzyme, this is a substrate. As you can see here, malonate is very similar to the inhibitor is very similar to the substrate, so it can inhibit. Do you understand? Clear? So we have another inhibition. This is non-competitive. Yani there is no competition. For example, again, you have this actually active site. Your active site occupied by your substrate. No matter substrate is here or is free. Okay? So as you can see here, inhibitor not only can bind, for example, inhibitor bind here. Okay? No matter your enzyme is free, it can bind, or sometimes enzyme bind to the substrate. Your inhibitor can bind here. Do you understand? So, when we say non-competitive inhibitor, yani there is no need for binding for the substrate and there is no competition here. But what is the effect? For example, I'm an enzyme, okay, and my hand is my active site. When I'm free, yani without inhibitor, I take my substrate and very fast I can do the reaction and synthesize the product. Okay? What happens whenever you bind, yani enzyme, bind to the inhibitor? For example, as I mentioned, there is no actually need for binding substrate or not. When I take my substrate, then the inhibitor bind, as I mentioned, inhibitor bind to the other part of the enzyme. For example, inhibitor bind to my leg. What happened to the rate of reaction? Slow yani effect on a velocity. Vmax. So as a result, Vmax increase or decrease? Decrease. Is it clear? So in the presence of non-competitive inhibition, your Vmax, you have to move very slowly, do reaction slowly. But because inhibitor does not bind to the substrate binding site or active site, it cannot affect Km. This is a rule, okay? Whenever inhibitor sits on active site, when you are talking active site, meaning you are talking about Km. But because it's outside of active site, Km, no difference, constant, okay? Clear? What is the example? Actually, we have a limited example of non-competitive. Just know that oxoprenol is a specific drug, actually is a metabolite actually of the oxoprenol, known as a alloprenol. Have you ever heard this name? Do you have any member in your family who take alloprenol? Have you ever heard the name of the goat? Negres. In Farsi we say negres. Negres goat, yani this is a rich disease. Rich disease when you eat meat a lot, okay? They can accumulate as a result of metabolism in some, for example, joints of the bone, for example, and by the alloprenol. So what is important in this slide? Alloprenol considered as a non-competitive inhibitor of xanthine oxidase. In metabolism, you will be familiar with the metabolism of the purine. Purine is found in, for example, in a meat. In some actually food stores, you will be familiar. But just know that for your level. Alloprenol is a drug considered as a non-competitive inhibitor, inhibit which enzyme? Xanthine oxidase. In the previous slide, we talked about reversible reaction, reversible inhibition. Also, we have an irreversible inhibition, and yani whenever your inhibitor binds to your enzyme, you cannot remove it. They known as an irreversible. What are the examples? For example, lead as a metal can bind, for example, here. You have active site. An active site of enzyme, you have a sulfhydride. Sulfhydride means SH. Okay? And the name of this enzyme is ferrochelatase. Ferrochelatase is a key enzyme again in the metabolism of nitrogen molecule. You will be familiar with the metabolic pathway of the heme. Okay? When you inhibit the production of heme, what happens? Anemia. Okay? When you cannot synthesize heme, yani you cannot synthesize hemoglobin. When you cannot synthesize hemoglobin, so you have an anemia. So, lead as a metal can cause anemia. Why? Because it irreversibly inhibits the key enzyme ferrochelatase during the heme synthesis. Another example, aspirin. Have you ever heard this name? It's very common. Anti-inflammatory actually drug. Aspirin can inhibit the cyclooxygenase and it can control the inflammation, fever, many actually symptoms. And what about penicillin? Antibacterial agent. It can inhibit the transpeptidase, inhibits the synthesis of bacterial cell wall. These are the key points of this slide. So all of these examples belong to the irreversible inhibition. And this is a mechanism action, there is no need. What's important, just know that in a transpeptidase, you have one amino acid serine here. What is the R group of serine? It contains OH, okay? So, antibiotics bind here. Just know that the active site contains, if I ask you which amino acid, this is a serine. And about the, have you ever heard the captopril, antihypertension drug?
It's basically antihypertensive drug. It's really famous because the way it was
In
made,
Iraq also it's famous? In Iraq.
no, like the way they made it was like a jump in the focus of drug design. I think they extracted it from a snake poison in Brazil. It's a lot of stuff. But yeah, I see.
Do you know what is the actually target molecule for? Excellent. What is the AC abbreviation of what? Full name is? I mentioned here.
Angiotensin converted enzyme.
Okay, so you know if you want to control the hypertension, okay, you have a different way. One of them is controlling the production of one important molecule, and this is angiotensin 2. You know, in our body, you have a conversion of 1 into 2 by the angiotensin converting enzyme. What is the role of this molecule? Angiotensin to contract your blood vessels. Okay? انقباضات. Contract your blood vessels. And by this way, your blood pressure increases. And for the other symptoms, inshallah, other symptoms you will be familiar. They secrete renin, aldosterone, they absorb sodium from the urine. So sodium is a hypertension marker, okay? For several ways. Not just for this, actually. It's like just know that whenever you have a production of angiotensin 2, you have a vessel contraction. Okay? It can increase the blood pressure. It can cause a hypertension. Okay? So, if I inhibit the production of angiotensin, you have a relaxed blood vessel. Yani you can control blood pressure. So, what is the name of the drug? Captopril, enalapril, the name of the enzyme, and this is the irreversible inhibition. Is it clear? Was it?
Yes.
And the other part of my lecture will focus on a regulation of enzyme because it is the basic of some part of your metabolism. As I mentioned, metabolic pathway controlled and catalyzed by the enzyme. Okay, so yes, you have to control the activity of enzyme. You have to manage. You know, for example, enzyme are your co-worker. Okay, you have to manage their activity. We have a different strategy, like for example, motor traffic. Metabolic pathway actually flows more efficiently whenever you regulate the cycles, you regulate the pathways by some specific strategy. We have a 6 major strategy about the location of enzyme in the cell. For example, sometimes your enzyme, I know, in high school you know, some enzymes are present in a cytosol, some of them in mitochondria, okay? So localization is very important. Allosteric control, I will talk about it. Have you ever heard about the isoenzyme? Different form of enzyme, I will talk about it. Covalent modification, we talk about a little. Phosphorylation, for example, and dephosphorylation. I will talk about and proteolytic activation and control the amount of protein. Inshallah, you have a 4th session for molecular biology. And Dr. Panahi will describe all the details of the last strategy. Now, I want to have a fast review about this one. As I mentioned, we have a different parts in our one school. I heard of some whisper. Who is talking? Nothing? As you know, we have a different, actually, metabolic pathway. I don't know, glycolysis, Krebs cycle, fatty acid oxidation, okay? We have a compartmentalization. What does it mean, compartmentalization? Yani, you separate specific enzyme and you send them in a suitable environment. For example, in a lysosome, what is lysosome?
It's an organelle in the cell. It the microorganisms and the stuff inside the cell.
Inside of lysosome, which molecule? Enzyme. What is the pH of lysosome? Acidic. Okay? So, whenever you want to have a good activity for the enzyme in the lysosome, for example, the pH of lysosome is 5. If you send them out, cytosol is 7. They became inactive. So compartmentalization, yani you put the enzyme in an appropriate site, in a suitable site, lysosome. For example, you want to have a better activity for TCA cycle, Krebs cycle, fatty acid oxidation. They are actually stable in a mitochondrial environment. So you put all of the enzyme of these cycles and pathway in a mitochondria. For example, glycolysis is you send, for example, kinase and other enzyme of glycolysis in a lysosome. Lysosome is acidic. They digest all of the enzyme of the glycolysis pathway. You know? The appropriate site, yani, you put your enzyme compartmentalization, yani, you put your enzyme in an environment that is suitable for your reaction. What about the allostric? Allostric, we talk about this word. What about the origin of this word? Alloesteric, yani, allo, yani other from the Greek word. Okay? Allo, other esteric, yani space, jab, faza. Okay? Other space. Allostric enzyme, as I mentioned, most of them catalyze the beginning of the metabolic pathway. They consider as a regulatory enzyme. Yani, you can activate them, you can inhibit them. Is it clear? So, as I mentioned, although yani, they have a other site rather than active site. For example, the active site is here, the allostric site is their leg. If you want to activate, you add some positive molecule to fast your pathway, okay? To increase the rate of your pathway. If you want to inhibit, you add the other side, okay? You add from other side. So they have an other side. Other side yani allostericity side, yani regulatory side. About the subunits, they have a catalytic side, C side, yani substrate binding side, other side, regulatory side, now as a R. We talk about inhibitor and activator. Yani inhibitor, inhibit the reaction, activator, activate your reaction. No matter this is inhibitor or activator, generally we say that effector. Any molecule, what is effector? Any molecule affects your activity. No matter this is activator or inhibitor. And like a hemoglobin, it has a high affinity to substrate, R4, low affinity, T4. Exactly like hemoglobin. We talk about this one, just know that whenever we are talking about common enzyme, Michaelis-Menten, hyperbolic, allostric enzyme, sigmoidal curve. Is it clear? And it's very clear in this. Most of the time, I never ask you from this slide, okay? Just I want to know, maybe, because I promise, maybe some true and false question, okay? I ask you, for example, some true and false. The positive activator and negative activator. Because I know that you understand the effect of Km and Vmax, you can answer me, okay? I'm talking about activator. Please tell me. Positive activator. What is the effect of positive activator? I'm talking about allostric enzyme, okay? When we are talking about allostric enzyme, activator yani effector, inhibitor yani effector. Is it clear? Yes. So, I want to repeat my question. About actually the effect of some molecule, yani effector on allostric enzyme. Please tell me, in the presence of positive effector, what happened to Vmax? Positive effector. You are talking about allostric enzyme at the beginning of your pathway. You add positive effector. What happened to the velocity rate? Increase. Yes, it's clear. Increase. So, what is the effect of positive effector on a Km?
Constant.
Km. Positive effector. No, positive effector. Forget about inhibitors.
KM decrease.
Km no. When your Km increase, what happened?
We said
No, you know it means that it has not a good effect of your enzyme, okay? When you have a positive effector, yani you can choose your substrate very easily. Okay? Yani your affinity
high affinity.
increase, yani Km decrease. Clear? So, what about negative inhibitor? Negative inhibitor, and I want to review my question. About the negative inhibitor, what is the effect of negative effector on the Vmax of allostric enzyme? Negative on a rate of reaction. Slow. Yani rate, actually your rate actually decrease. What about Km? Negative effector. Increase. Excellent. Yani when you add a negative inhibitor, I made a mistake about it. Whenever you add a negative effector, it can cause a decrease for your affinity. So, yani Km increase. One second, okay? This is the concept of this slide. What about the nature? Yes. You didn't understand? Was it? you have an allosterate effector, allosterate enzyme. You can control the activity of allosterate enzyme. When you can control the activity, the molecule can control known as a effector. Okay, is it was clear? Effector can be negative, can be positive. When we say negative effector, yani bad factor. When we say positive effector, yani accelerate the rate of reaction and help you. Okay, so I want to repeat my question. I'm an allosterate enzyme. Please tell me, what is the effect of positive effector on a Vmax? Increase. Effect of negative effector on a Vmax? Decrease. Slow. Effect of positive effector on a Km? You love high affinity and what about Km?
Decrease.
Low Km. Do you understand? What about the negative effector? You didn't like low affinity, high Km. Is it clear? Inverse. Actually, there is an inverse relation between actually negative and positive. Do you understand? When you have a negative effector, yani it didn't want to take your substrate. It decrease your affinity. Okay? So when we say decrease affinity, yani increase Km. Okay, clear? True and false question. For example, positive effector, for example, decrease affinity, decrease Km, decrease velocity, any kind of this question. And some effectors actually can classify according to some specific characteristics I will tell you. You know, we can say that effector considered sometimes as a, what is homo and hetero? Because I know that you have a homopolysaccharide and heteropolysaccharide. Do you remember? Homopolysaccharide like a glycogen, like a cellulose. يعني فقط this وحدة موجود. فقط glucose. Okay? Same units. Okay? For example, about GAG, glycose aminoglycans. Glucose amine and acetyl glucose amine glucuronic. These are repeating units. More than one time. يعني hetero. Okay? So, when we say homo, it means that same actually. It's better to say. Hetero means that other. But I'm talking about effector on an activity of enzyme. Homotropic effector, يعني substrate. What does it mean? And more at first. يعني, most of the time we can say that substrate is positive effector. What does it mean at first? By definition, as I mentioned, because I want to repeat at first the concept, homo and hetero effector. This is the rule. When your effector, this is the enzymatic reaction, okay? And this is enzyme. When your effector, yani molecule, can control the activity of enzyme, when it's substrate, again, it's considered as a homotropic. And this is a positive. Yani what? Yani, for example, I'm a glucose. Okay, I'm a glucose. And I want to describe this glycolysis because I know that you are familiar with glycolysis. Okay, so you should know that glucose considered as a positive effector for the glycolysis pathway. Yani glucose say that, hey, I'm here, increase the rate of reaction. Yani positive effector. Do you understand?
Yes.
So when your substrate is similar to your effector, it is a homotropic effect. This is the simplest way to describe the homotropic. But what about the heterotropic effect? Heterotropic effect yani other molecule. For example, your glucose as a substrate. A molecule that would control your activity, for example, is, I don't know, citrate, malonate. The nature is different from substrate, okay? So the effector